Let's look at proposition 9 of book 2 of Euclid's Elements. Given a line segment, we cut it into half. That is, we figure out the midpoint. We know how to do that. We quickly do that. So C is our midpoint, and we take a point on this line segment AB in such a way that we get two unequal parts. What the proposition says is that AD square plus BD square is equal to 2 times AC square plus CD square. Okay, and now uh, in many of the previous propositions we have been constructing squares. Now instead of that, let's do it slightly differently by creating triangles. Okay, which is what Euclid did. Next we will draw a perpendicular to AB at C. We already did that, remember, to figure out the midpoint. So we have this line. On this line, we have to cut a line in such a way that it is equal to either AC or BC. Since they are both equal, it doesn't really matter which one we take. So we draw a circle at C of radius AC. And we take the intersection. We are interested in only one intersection. We join these points. Okay, now what do we do with this D? D could be anywhere here. What we'll do is we will draw a line at D which is perpendicular to AB or CD. So now we have this line, a perpendicular line to AB. Now we have an intersection point with this BE. Next, what we have to do is draw a line parallel to AB at F. So let's do that. We get the intersection point G. So let me get rid of this circles and lines. And we join these points. So now look at this. This is perpendicular, so 90 degree. Similarly, this is perpendicular, so this is also 90 degree. Angle BDF. Now we have to prove that AD square plus BD square is equal to 2 times the sum of AC and CD squares, or sum of AC square and CD square. Okay, now let's zoom in a little bit. Okay, now let's look at triangle CAE. In this triangle, this is 90 degree. CE is equal to AC. So that means angles opposite to equal sides are equal. So that means CAE is equal to AEC. Similarly, in this triangle, BCE, this is 90 degree, right? And CE is equal to BC. So again, sides are equal. So opposite angles will also be equal. So that means angle GEB or CEB, both refer to the same angle, are going to be equal. So this angle is equal to this angle. Okay. Now let's look at this angle. GF is parallel to CB and FB is a traversal. So that means this angle, corresponding angles will also be equal. So that means EFG is equal to this angle. Since this angle is equal to this angle, that means they are also equal. Now, this angle will also be 90 degree, right angle. Why? Again, because this line is parallel to this line and CE is the traversal. So that means corresponding angle will be equal. So FGE will also be 90. Now, in a triangle, the sum of the internal angles equal to 180 degree. This is 90 degree and these two angles are equal to each other, that means they both are 45 degrees. Similarly, if you look at this triangle, this is 90 degree, sum of these three is 180 degree. These two angles are equal, that means they are both 45 degree. So that means this AEC and CEF or CEB both are 45 degrees. That means this is 90 degree. So let me mark it as 90 degree. So now this is 90 degree means what? We can apply proposition 47, that is Pythagoras theorem. AC square plus CE square equal to AE square. So we got AC square. Now we require CD square also, because BD square we can again get it, because again the same rule applies, that this angle will be equal to this. Why? Because this is again going to be 45 degree and this is 90 degree. That means this has to be 45 degree. So here again BF square is equal to BF square plus BD square. So we have got AB square, an expression for AB square, which can be written as AC square plus BC square. We have got CD square. Why? Because CD is equal to GF. And we know EF square is equal to GF square plus GE square. So GF can be substituted with CD square. So we have got an expression for AC square. We have got an expression for CD square. We have got an expression for BD square. But they're a little bit, different expressions. So we have to combine. So for that, what we'll do is draw a line segment joining A and F. Okay. Once we join this, then we get AD square also in an expression. AF square is equal to AD square plus DF square. And since this is again a right angle, we can say that AF square is equal to AE square plus EF square. Okay. So now remember AC and CE are equal. So instead of referring to CE square, we can double this. We can say AE square is equal to 2 times AC square. Right? Similarly, EF square is equal to EG square plus FG square. But FG is equal to CD. Again, since these two sides are equal, we can say that EF square is equal to 2 times CD square. AF square is equal to AE square plus EF square in this triangle. But we have already seen that AE square is 2 times AC square and EF square is 2 times CD square. So we can say AF square is equal to 2 times AC square plus CD square. Now AF square can be written as AD square plus DF square, since this angle is also right angle. So AD square plus DF square is equal to 2 times AC square plus CD square, and DF is equal to DB. Again, these two angles were equal to each other, which means that these two sides are also equal. So instead of saying DF square, we can say DB square. So we have arrived at the expression AD square plus DB square is equal to 2 times the sum of AC square and CD square. So that is proposition 9. Again, if you want to read through this proof, you can refer to my book where I describe all these propositions, and The link to that book is available in the video description. So that's it. Bye.